What's up, math fans? Today we're going to be doing dividing of algebraic fractions, and you know how they say you gotta crawl before you walk and walk before you run? Math is kind of like that too. You have to build. We're building to get to somewhere, to a goal. So you need background knowledge. So hopefully you already saw my video or you learned in class how to multiply algebraic fractions, because you need to understand multiplying before dividing. In fact, in the video I list all the background knowledge that you need, so that way I can run through it in this video without explaining every little detail again. Alright, so here's how I conceptualize dividing fractions. Think about if you have, I don't know, 10 cookies, right? Well, let's look at this problem. If you look at it really quickly, when I look at it, I'm thinking the answer is 10 divided by half. I'm thinking the answer is 5. A lot of people make that common mistake. Well, think if you have 10 cookies and you want to divide them all in half, or you want to cut them all in half. So how many halves or how many pieces would you have? If I take 10 cookies and I cut them each in half, I'm actually going to have 20 pieces. So then mathematically, how do you get the answer of 20? Well, this is what is done. The 10 gets multiplied by the 2. So what happens here is the 10 actually gets put over 1. The division changes to multiplication, and the half gets flipped and becomes 2 over 1. And then you multiply straight across. 10 times 2 is 20. And then 1 times 1 is 1. You don't have to put the 20 over 1. Only rookies do that. So your answer is, I will have 20 pieces of, or 20 cookie pieces. Alright, so what's my point? My point is the rule for dividing fractions is actually to turn it into multiplication by remembering keep, change, flip, or I say stay, change, flip. First fraction stays, the division changes to multiplication, good thing you're good at it, and then we flip or find the reciprocal of that second fraction. So if you look at number 1, try it on your own and then follow what I do. In fact, I would try all 3 of these on your own, and then I'm going to walk you through this one because this one's a fun one. It's a nice bonus question at the end. Alright, so I'm going to follow keep, change, flip, or stay, change, flip. 7 over 10 stays. I'm going to change division to multiplication, and then the reciprocal of 21 over 5 is 5 over 21. In fact, it might be better to write the 10 and the 21 in factored form. You can write them as 5 times 2 and 7 times 3. And the reason I factor these is so that I can cross cancel. So this 5 up here gets canceled with that 5, and the 7 gets canceled with that 7. And my final answer is whatever's left. Well, that's 2 times 3, so the answer is 6. Okay? But of course, you can't forget that the 6 is on the bottom. It's a denominator. So what's on top? 0? Nothing's there, right? It's not 0. When things get canceled out, they got divided. Well, 7 divided into 7 once. They actually get replaced with 1s. The reason I don't write the 1s on the bottom, because 1 times 2 is still 2, and 1 times 3 is still 3, so 2 times 3 is 6. But you remember on top, 1 times 1 is 1, okay? So, try not to forget those little minute details. All right, now I throw some letters at you, but the plan is still the same. The plan is keep the entire first fraction the same, change to division, and then I'm going to flip that, so that should be 5c squared d squared over 14b to the third. And again, I could have written it in factored form as 7 times 2, so just keep that in mind. I'm actually going to not do it because I already know. So 7 goes into 14 twice, 5 goes into 10 also twice, nice coincidence. There's an a up here. There's no a down here, there's no a down here, so I'm going to leave that a. Now I see a b squared and a b to the third. So if you think about what b squared means, it means b times b. There's 2 b's up here, and b to the third means b times b times b. There's 3 b's down there. So basically you're subtracting exponents here, and this will kind of leave you with just a b. Alright, because 2 of the b's get crossed out and leaves you with a b down here. Same story for c, and c squared leaves you with a c. D and d squared would leave you with a d, and whatever is left over is your answer. So I'm going to multiply straight across. A times c times d, a, c, d, over 2 times 2 times b is 4b, and we're done. Okay, I will try it on my own, and then of course if you catch me in a mistake, feel free to comment and you will win a prize. Alright, next, here, again, dividing fractions. Oh, what do you mean? Those aren't fractions. Of course they are. If you ever see a term, binomial, trinomial, whatever, an expression that's not a fraction, you put it over 1. Magic, voila, it's a fraction. All right, so we're gonna keep, change, flip. So the first fraction stays exactly how it started. 9. Actually, you know what I'm gonna start to do? I'm gonna write it really small because I'm gonna wanna factor it. So I got 9 minus y squared over 1 times 2y plus 10 over y squared plus 8y plus 15. When you do this enough, you can skip this step. Because what I want to do is now factor, all right? So if I see 9 minus y squared, hopefully you're comfortable enough with dots, difference of two squares, and you know this is 3 plus y, 3 minus y over 1, okay? Remember, the number came first here, so the numbers have to come first here. Don't switch it around, it complicates things. 2y plus 10, well, that looks like it calls for GCF. So this is times 2y plus 5, because I factored out my GCF. 2 goes into both 2 and 10, so that leaves me with y plus 5 over. Now this guy requires the use of factoring again, but this time sum product. So what times what is 15? It also adds to 8. Well, that's going to be y plus 5 times y plus 3. I hope. Of course, you're doing it on your own to check. What happens now is the y plus 3 and the 3 plus y, those are exactly the same. If there's a plus sign in between and you switch the terms, still the same. That's the commutative property. So, goodbye. Y plus 5's, goodbye. Whatever's left over, let's see, 2 times 3 minus y on top, and nothing on the bottom. So that is my final answer. Well, 1 is on the bottom, you don't have to write the 1. All right, there's your final answer. You want to be slick and distribute the 2, that's fine. Leaving it in factored form is just as good. All right, and finally the bonus question. Try it on your own, let me know what you get. If this is multiplication, I'm not flipping anything. People learn keep, change, flip, and then they just start flipping all willy-nilly. No, you're only flipping the term that's being divided. So this entire thing is going to stay. If you want to multiply it first, go for it. I'm not. This whole thing stays. This changes to multiplication, and then this is going to flip. And I'm going to factor while I do that. So x plus y, can't factor it. Ooh, look, a sum of 2 perfect squares. Did I ever learn how to factor that? Nah, I don't think so, so I have to leave that alone too. Oh, can't factor that, and I can't factor that. This isn't a very fun question. There's nothing to factor here. This is just practice, not being overwhelmed just because you see a bunch of stuff. Don't be overwhelmed. It all stays the same. Now, I'm going to change, and then I'm going to flip. X to the 4 minus y to the 4, those are a difference of 2 squares. That becomes x squared plus y squared, excuse me, and, don't panic, I'm still here, and x squared minus y squared, because x squared times x squared is x, x to the 4th, and y squared times y squared is also y to the 4th. So you notice I flipped this, now this is on top and it's factored, over, what is this, x plus y squared, what does it mean? People try to do so much math they forget what it means. It just means write this base twice. So that's x plus y times another x plus y. You know what's really cool about this question is something called factoring completely. So you think you factored so you're done. I could look at this guy, it's another difference of 2 squares. You can go again and you can factor this as x plus y times x minus y. So that becomes that. Now it's completely factored and now I can start canceling out. So I see x squared plus y squared, x squared plus y squared, goodbye. X plus y, goodbye. X minus y, goodbye. And whatever's left is looking like x times x plus y on top. Oh, no, look at this. X plus y, goodbye. So it's looking like everything got crossed out except for this sole survivor, the x. All right, stay, change, flip. You're good to go. Thanks for watching. See ya.